Okay, so on the green, here we go. So we start with x squared plus 5x plus 25. So my a times c here is 25. This is 10. It gives me 5 and 5, which is x plus 5, x plus 5. So I could, what? What? Right. So this is a perfect square as far as factoring goes, because I can write this as x plus 5 squared. Okay? These are the same thing. So this is just written as a perfect square, because it's the same, it's the times itself, and it's the same. So on the next one, I have 3x squared plus 12x plus 12. So what do I have to do to start this one? Okay, so I hear lots of words, the GCF, not, yeah, so there's no fractions, that's okay, but let's get the right language, right? So we want the greatest common factor. And so the greatest common factor is 3, so I'm going to divide out of 3. Isaac. So my a times c now is only inside the parentheses, so that's 4 and 4, so that's 2 and 2. So I end up with 3 times x plus 2, x plus 2. And again, that was a perfect square, and we could write that as 3 times x plus 2 squared. It wouldn't. It wouldn't. And so I didn't forget the 3. Oh, no, you got to have the greatest common factor. It's wrong. But if you write it this way, I won't count it wrong. So either one of these is okay. Okay? But I want you to know this, because we're going to do something with that today. All right. So the next one is what you had questions on your homework about. Okay. So what gave you a problem here? There's 2 different variables, right? So if I just ignore the y to start with, just ignore it like it wasn't there, what's my a times c? I get negative 11 and 10, correct? And so my factors are going to be positive 11, negative 1. Right? Those, because you want a positive 10, right? And they have to multiply to negative 11. So I think I heard negative 10 and 1, but that wouldn't multiply to negative 11, right? But when you do this, it will. All right, now here's my question. So when I do this, I take the x, and what do? It's x squared. What do I write down here? X and x, right? So what would I multiply to get y squared? Just to get the y and the y, right? So if I put plus 11y minus 1y, so let's check. X times x gives me 11y times a negative y gives me negative 11y squared. And then in the middle, 11xy minus xy gives me 10xy. Because 1 is positive and 1 is negative. So all I did to get the extra variable in there, I put it second. Does that make sense? Okay, so let's do another one. Wait, and I think this is the one there's a typo on. Oh, no, it's the next one. Okay, so this one. What's my a times c? Because there's no greatest common factor this time. Negative 6, negative 5. So if I choose negative 2 and negative 3, that multiplies to positive 6. Negative 6, positive 1. Okay, so now listen, my friends. This has a leading coefficient. So I'm going to have to start this one with 2x and 2x. And I have a second variable, don't I? So this time I have to add the y. So I'm going to have negative 6y plus y. Does the first one simplify? So I divide by 2, and I'm going to get x minus 3y times 2x plus y. There is a typo on the next one, though. How did you know it? Change the 5 to a 7 and make this a minus. The 5 to a 7 and make it a minus. So my a time, first of all, is their greatest common factor? No. So look, what's the difference now? This exponent and that exponent. It's a 4 this time, right? So let me ask you, this is a 2. What's the exponent on the x? The exponent on the x. That's 1. The exponent is 1. All right? So when I wrote this, x squared, I multiplied the x times the x and got x squared. So what am I going to multiply to get x to the 4th? X squared, right? And look, if I make inside my parentheses x squared, that makes this x and y squared. It's always going to be half. And that's always going to work. And it's going to be okay. That's right. I like your sarcasm a little bit today. 6 times negative 3 gives me negative 18 and a positive 7. So the factors are 9 and negative 2. So I'm going to write 6x squared plus 9y squared. 6x squared minus 2y squared. Can the first one reduce? By 3 and the second one by 2. So I'm going to get 2x squared plus 3y squared times 3x squared minus y squared. I did. Yes. Very similar to this. Okay, so the next one. First of all, it says 16x to the 4th. What kind of example is this an example of? It's a perfect square. Even though it's a 4, it's still a perfect square. So how would I write that? Perfect. So if I start like this, 4x squared plus 1 and 4x squared minus 1. Are we done? What else factors? The 4x squared minus 1 also factors. The 4x squared plus 1 is prime, right? It doesn't factor. But the 4x squared minus 1 does factor. So my final answer is going to look like this. Okay, so does that answer your questions from the homework? Yes? The 4th and the x and the y? Okay, so the sum of cubes and the difference of cubes. Okay, so we did this also last year, and this is, you just follow the formula, right? We just follow the formula. There's no There's nothing else you can do. Just follow the formula. So, if I look at 27x to the third, what number cubed gives me 27? 3. So, I'm going to have 3x to the third, and this is my a. And 1 cubed is 1, so that's my b. So now I'm following the formula, a plus b. Well, what's my a? It's just the 3x, not the cubed, just the 3x. So I'm going to get 3x plus 1. And then what does it say to do? A squared. So my a is 3x. What's 3x squared? 9x squared. And then it says minus a times b. So minus 1 times 3x, so that's 3x. And then plus b squared is plus 1. And that doesn't factor. That's the answer. And that's all you're going to do. So 8x to the third minus 64. First of all, is there a greatest common factor? Yes. So if I take out the greatest common factor, so what's my a in this case? Just x. And my b? 2. So I'm going to use my 8. I'm just going to write it in front. 8 times. So I'm going to take a minus b. So that's x minus 2. A squared gives me x squared plus a times b is 2x and b squared is 4. That does not factor. Where would that have come from? It didn't. What number cubed is 8? 2. Okay, so here's a hint to help you remember. Yes. So whenever you do these, you do SOAP. It's same, opposite, always positive. So look, it's always A and B, and you take the same sign. So this is minus, that's minus. Then I do the opposite. So my next sign is the opposite of minus, which is plus, and then the last one is always positive. The same works up here. You do the same, this matches, opposite of this, and the last one's always positive. Okay? All right. So the next way to factor is this. You did all of this last year. When do I use the quadratic formula? So over here, the x squared plus 2x plus 4, it doesn't factor, right? But you can use the quadratic formula and get roots. So when you can't factor it, you're going to use the quadratic formula. So what do I have to do before I start the quadratic formula? If it's written like this, I have to put the 2 on the other side. So I get 2x squared minus x minus 2 equals 0. So my a is 2, my b is negative 1, and my c is negative 2. My b squared is 1, 4ac is negative 16. Whew. And 2a gives me 4. So when I fill this in, it's a negative b, so minus a minus 1 is 1, plus or minus the square root of b squared is 1, minus a negative 16 gives me plus all over 4. So the factors for this are x equals 1 plus or minus the square root of 17 over 4. And so you wouldn't have been able to come up with those factors in your head, but we can quadratic formula and get the answers. Now, does everybody remember the quadratic formula? Everybody knows how to do this? Right, that would be it. Now, what if I would have gotten this for an answer? What do I have to do with the 20? You have to simplify it, right? So you have a pair of 2's here, so the 2's can go on the outside. And can this reduce? It can. And so it's going to look like this. What's different, Isaac? That hurt? It didn't hurt. It's okay. Yeah, you do. Because now what happens? The 2 over 4 reduces to the square root of 5 over 2. Okay, there's one more kind. Complete the square. So we use the quadratic formula to get the x-intercepts when you can't factor. We use completing the square to get to vertex form. Use completing the square to get to vertex form. And so teachers teach this a bunch of different ways. And so I don't know how all your teachers taught you. So I'm going to work the problems the way that I'm going to write them. Okay? And so hopefully something will click with you. If not, pay attention. So if this is the problem, so the goal in completing the square is I want to get it in perfect square form. That's my goal. Okay? And this is how I'm going to do it. The first thing I'm going to do is I want the x's to stay on one side and the numbers to go to the other. So I'm going to have x squared minus 16x, and I'm going to move the 8 to the other side. And so what I want to do is I want to write this as a perfect square. I want x squared minus 16x as a perfect square. So if I do b, my b is negative 16. And so what I'm going to do is I'm going to rig the problem so it's a perfect square. And the way I'm going to do that is I'm going to take b over 2. So negative 16 divided by 2 gives me negative 8. And my last step is I want b over 2 squared. So negative 8 squared gives me 64. So this very last number here, it rigs it so this is a perfect square. So I'm going to take the 64 and I'm going to add 64 right here. But what I do to one side, I have to do to the other. So I'm going to add 64 on this side also. So now this side, I can write it as a perfect square. Because what are the factors of 64 that are going to give me negative 16? So this number right here is how I'm going to write it as a perfect square. So if you take the b, you divide it by 2, that's your perfect square number, and the squared number rigs it so you can write it that way. So here, I get x minus 8 squared, and it equals 56. Negative 8 plus 64 gives me 56. So I just want to subtract the 56. So the vertex of the quadratic is 8 and negative 56. Because now it's in vertex form, and that gives you the vertex. So let's do another one. What's the first step? Add the 20. So x squared minus 4x, put the 20 on the other side. Now we want to write it as a perfect square. So my b is negative 4, my b over 2 is negative 2, and my b over 2 squared is positive 4. So I'm going to add the 4 to both sides. I'm going to write it as a perfect square and subtract the 24. So is everybody okay with that? Do you want to see one more of these? I have one more different kind to show you. Do you want to see one more of these or go on? One more? Okay. Let's do this one. Trey, you're absent? Well, you didn't check off that you're here, so you're a big fat absent. Alyssa, you're absent? Big fat absence. Who else? Aaliyah? She really is. Casey is absent too. Savannah. You checked the wrong one. Do I need to give a lesson on taking attendance? Clearly. Cassie. No, not you. Wrong. There's 3 of you. One of you check for all of you. Okay. First step. First step. Move the 9, right? So my B is 18. My B over 2 is 9. And my B over 2 squared is 81. So I'm going to add 81. What? Yeah. Yeah. It's not like I go home on Friday night and complete the square with my husband for fun. Oh, sweetie, it's Friday night. Let's do the quadratic formula. No, we are not that couple. Mm-mm. Okay, yeah, we go running. Okay, one last one I want to work. It's still a completing the square, but it just looks a little bit different. You can do it wherever you want. So what's different with this one than the last one? Well, it does have a GCF, but it starts with 2, right? The last ones didn't have a coefficient. So it doesn't matter what the coefficient is, all right? So I'm going to work this exactly the same way. I'm going to move the 6 to the other side to start. Now on this side, I just want to take out the 2, all right? So I'm going to have the x squared plus 2x, and I'm going to put the 2 in front. No, not the, yeah, just the 2. Because I still want to complete the square. So I'm going to leave the x there, okay? So my b this time is 2. b over 2 is 1. And b over 2 squared is 1. Yes. So this, I put plus 1. Now listen to me. Everybody write this down and then watch. Did y'all write this down? Okay. So I put the 1 there because that's my b over 2 squared, correct? But what did I divide this side by? So how much did I really add? I added 1 times 2, which is 2, correct? So what do you think I have to add to this side? I have to add 2. So whatever you add in here, you have to multiply by the outside number to add to the other side. So that's the only difference. No. So then I'm going to write this as a perfect square. And I'm going to move the 4 over so it's set equal to 0. So now, after I'm at this step, what's the vertex? -1 and 4. And why is it -1 again? X's lie. That's why they're your X's. So what is the 2 on the outside? That's your stretch. It's bigger than 1. It's a stretch. Isn't that amazing? I know. All of you stay in your seats. Do not get up and cheer. But that's where your stretches come from, right? It's either a stretch or a compression. And so if it's a half out here, it got compressed. I know. I love it too. It's so exciting.